When you hear the phrase global warming, it is probably the average temperature of the Earth that comes to mind. This clip shows the temperature change at 2 meters, 6.6 feet above ground for the years 1950 through 2100. The red indicates temperatures above the level around 1900, the blue below. The figure on the right shows the change in the global average of the surface air temperature. There is a natural variation in temperature with ups and downs, but a gradual, steady increase is discernible. Our projections suggest that compared with 1900, the temperature is going to rise by 2 degrees Celsius, or 3.6 degrees Fahrenheit by 2028, by 3 degrees Celsius by 2052, and by 5 degrees Celsius by 2100. These figures are at the high end of the possible temperature range. This image shows the same surface temperature but from a different perspective. Global warming does not mean that the Earth warms up uniformly. For example, look at the North Pole and the Himalayas. These areas are currently covered by snow and ice, which are white and reflect sunlight efficiently. Global warming melts away snow and ice, exposing black soil and ocean. Thus, more sunlight will be absorbed. You can therefore see a higher temperature rise here compared to other regions. Also, notice a higher temperature increase over land than in oceans. Two factors account for this difference. First, land has a smaller heat capacity than ocean and is easier to warm up or cool down. Second, evaporation releases a great deal of heat from the ocean surface, but that much evaporation will not occur over land. How will precipitation change? Will we get more or less rain and snow? This clip shows how much precipitation will change compared to the 1900 level. The blue signifies an increase, and the red a decrease. As the Earth warms up, there will be more water vapor retained up in the atmosphere. On a global average, rainfall will increase, as will surface evaporation. Scientists predict that the Earth's water cycle will be more active in the future. Global warming would bring more precipitation in high-latitude regions and over tropical parts of the Pacific Ocean. On the other hand, rain will decline in places like the subtropics, where rainfall is already low. Soil moisture content is a measure of how wet the ground is. Taking around the year 1900 as a reference, this figure shows an increase in blue and a decrease in red. Soil moisture rises if there is more rain and melted water from snow, and falls if there is more evaporation. Global warming makes conditions more favorable for surface evaporation. Except for regions where precipitation increases considerably, the ground tends to dry up. For example, have a look at the drying of the Amazon. This simulation doesn't include the effect of soil dryness on plant growth, forest fires, and deforestation. Once we include these, the drying of the Amazon could be even more severe.